Lecture 34. Let's continue to talk about the streaming framework. I will present another solution, forwarding-unicasting solution. Let's take a look at the code, the design, the overall design. We have talked about that. So this time we just focus on the code. Take a look at the code. After that, if I will show the demo, but I'm not sure whether we have enough time for this lecture. So if not, I will show this demo in the next lecture. Okay, we can start from here. Start from the root. According to, it's better for us to take a look at this diagram. Within this diagram, this is the root, right? This is the root. However, for this time, within this multicasting framework, we use unicasting rather than broadcasting. Last time, we used broadcasting to transmit the stream. However, this time, we use multicast. So let us take a look at this code. Okay, this is a starting point. You must see this structure many times. And this is the peer. The root should be a peer, so you can see that this structure is exactly the same as a peer. And it's better for us to make a comparison with another solution, the polling and the broadcasting solution. Okay, this solution is here. This is the root. This is the root. Start streaming root. Okay, this is root. This is one distribute node for the multicasting, for the broadcasting. They use broadcasting to transmit the stream. Okay, you can see that this structure is same. This structure is same. That means it's easy to program with such a system. Okay, the code structure is that same. And next, let us open this service, a server dispatcher. Okay. Okay. Subscribe notification, that should be different from this one. You can see here for the broadcasting notification, for the broadcasting framework, no such notifications, no such message are processed. Why? This one, let us take a look what it is. Okay, you can see this is stream K is generated based on the publisher and the topic. Okay, this is subscriber and this IP address. Where is the information from? You can see, let's take a look, check. Okay, you can see this information is originated from the pub/sub server. We design another pub/sub server here. Okay, it's originated from here. This one is sent from the pub/sub server. Let us check this one. Okay, so that means one. This, you must have seen such request. This request is sent from the subscriber. When subscriber are interested in one particular topic, a stream, this request is sent from subscriber. It's sent from subscriber to the root. For example, this arrow, right? For this arrow, this subscriber sends such request to the publisher. That's this code. So after receive this code, then there's some information will be here. You can see here whether it check whether this subscription is successful or not. If it's successful, that means this stream the subscriber are interested in exists in the registry. So it checks whether such registration is successful or not. If it's successful, then it will contact the subscriber. The pub sub server will get IP address. Will get the IP address from the registry server. You can see this is the IP address of the registry server, and this is the K. The K. What is the K? Okay. The K is a subscriber. So through this invocation, through this method invocation, the IP address is obtained from the register server. Okay. So here, the IP address is obtained from the register server, and then this address is kept on the registry. And after that, this notification will just say a sent from a subscriber to the root. That this line, this arrow, you can see here, the connection, the directed connection between the pub sub server from pub sub server to the root. That means the registry information, the subscription information is sent from pub sub server to the root. That is different what we have seen before in the polling broadcasting solution. No such information. This direct connection does not exist. But for this case, this subscription information is sent to the root. That means forwarding. So in this case, the forwarding means the registry information, not only the subscriber information, the IP address of subscriber are sent from the pub sub server to the root. Then that means when the child need to perform broadcasting between itself and the subscriber, it's not necessary for the child to access the published sub-server any longer. Okay, so here, this one after the subscriber register its information, the stream interesting on the pub sub server. This notification is sent from the pub sub server to the root first. Right? The root should got such information. This information forwarded from the pub sub server to the root. Let us take a look at this thread. What this thread does here. Okay, you can see here. After this notification received by the root, this information will be unicast. That's a very important invocation. This method, this is unicast, right? Unicast, I discussed unicast before. According to this K, you can see this unicast. Let us open this method. This is stream K. The first parameter is the stream K. The next parameter is the message. The message to be unicasted. And when this stream, when the message, the stream the sub notification is received. This is a message to be sent, but this message is sent according to the stream K. This is the nearest notification. That means this message will be sent to the child. The child has a K. Each child has a K. Each child is a peer. So each child has a unique K. Then a lot of child in the multicasting framework, but there must be unique one. The unique one, the K of the child, that is the most closest to this stream K. If so, this notification will be sent to such child. This notification is sent to that child, that K, whose K is closest to the stream K. Okay, so only one child must be able to receive this message according to the stream K. That's very important. That means the registry information of subscribers are distributed evenly and decentralized in a decentralized way. So that's different. So if the child need to broadcast information, broadcast the stream to subscribers, it's not necessary. It's not necessary for such child to access the pub subserver anymore. Okay, so that's very important. That's different from this implementation, right? This is broadcast implementation. This is unicast. Okay, unsubscription. Yeah, this is a reversed action. So if you understand subscribe notification, it's easy for you to learn what unsubscribe notification is. This one also sent from the pub sub server, right? Also sent from here. Okay, you know that message, right? We talked about this message before. This message is sent from subscriber to the pub sub server when the subscriber need to quit, when the subscriber want to change the topic. Maybe the subscriber are interested in another stream. If so, it need to send an unsubscribe stream notification to the pub sub server. Okay, so after this notification is received, then the unsubscribing the notification is forwarded again. The notification is forwarded again, and then the unsubscribe is unsubscribe, right? And the registry will unsubscribe relevant information, and then this is forwarding. You can see this is forwarding. This is use a synchronous notify to read the performance. Okay, they'll say the send to the root. Okay, so I think okay, another difference from that's that okay. Maybe okay, let us open this code. Okay, it's easy to understand. It's easy to understand this code. Okay, and this one is the same. This notification should be processed as well, because this notification contains the stream that should be multicast within this multicasting framework. But let us take a look at this one. But here the difference. Here how to process the stream notification, that is different from the polling broadcasting solution. And okay, let us take a look at this. For this case, it's easy. For the unicasting case, that's easy. The root just need to send such source stream through unicast notify. However, here that's a little bit difficult. So the root is responsible to select one child randomly from its all of the children. That is this line. This line select one child from the multicasting framework randomly, and then it saves such K in the notification. After that, this notification, the stream notification, will be broadcast to all the children. It's okay. You can see this approach must consume more computer resources because it's a broadcast, but it's flexible. It's fault tolerant. However, for this one, only one child receives such K. Only one child receive the stream notification. Which child will receive such notification is based on the stream. Based on stream again. We see such method before, right? Last time, just now we take you can take a look. This message is invoked 2 times, right? Last time we see this one, right? Okay, this time this method invoked when stream notification is received. But the when unicast is performed, the stream K is very important because according to the stream K, the system can determine, can decide, can select which child receives such notification. So for when the stream data is received, the data is unicast to the child whose K is closest, the most closest to the stream K. Okay, then that means the registry information of the subscribers and the stream are unicast to the child, to the same child, because the child is selected in the same way based on the stream K, based on the comparison between the stream K and the child K. Child K is a peer, right? The peer case. So if all the child have the unique K, the same child will be selected if the stream K is unique. If the stream K is unique, if the child K is unique and static during the life cycle of the multicasting of the streaming framework. So each time, if this K is static, if this K is not changed, the message that unicast must be received by the same child. That's you must import. That means only one child within this multicasting framework is able to perform broadcasting between itself and all the subscribers who are interested in one particular stream. Okay, you must understand this issue. So this case, for this solution, the most important issue is subscription information should be unicast, and the stream data also be unicast. That's the primary difference between this solution and that solution. Okay, so okay, after that I think you must be able to understand the system easily. Okay, have to explain the root. I think you have already understand. You already understand such a system. But I think I still need to emphasize this issue. In this case, even though the business logic is different, and even though the application, the distributed system have different solutions, however, in terms of code structure, in terms of the effort of developers, I think it's no additional effort is required in terms of distributed system design, right? The overall structure is the same and the code effort is repeatable. The code structure, the design patterns are exactly the same. That means it's easy for developers to implement the distributed system, even though the application, the distributed system, the computing requirements are totally different. This application is more complete than what we had done before. However, the overall structure, in terms of the design pattern, are identical. That's very important. Okay, let us take a look at the chart. Okay, it's better for us to make a comparison when we explain the code. Okay, the start point is same. This is the broadcast, right? This is the unicast. Let us take a look. Open this code. Open this one. Okay. This is the peer. The child should be a peer. That's easy to understand. Okay, but they're a little bit different. Here for this peer, only the root address is required. However, for this approach, in addition to the root address, the pub sub server address is also required. Why? Because for this case, the child is responsible for polling the pub sub server. One new data need to be broadcast to subscribers, so it's required for the peer, the child, keep the IP address of pub sub server. However, for this case, it's not necessary. Because we just say the information, the subscriber information is distributed using unicasting to the child. The child is not necessary to know the pub sub server IP address. The stream is also unicast to the child if the unicast is unicast upon the same stream K, right? Okay, that's a difference. Okay, it's the same thing here. Okay, the child is not only be a child in the multicasting framework, but also the child is also a root for another multicasting between itself and the subscriber. So this root is required. That's the same as this approach, the multicasting based approach. Okay, the broadcasting based approach. Okay, for that, because the pub sub address is required. So when the system started, the child need to interact with the registry server to get IP address of the pub sub server. But for this case, not necessary. Okay, this local K, why this local K is required for the broadcasting polling approach? Because this local child, when stream data is received, it's necessary for it to check whether it is selected to broadcast the newly received stream. It need to check this K. And however, it's not necessary for this solution, because if the data is received by such a peer, that means this child, if the new data is received by such a child, that means the child is also responsible to perform broadcasting between itself and the subscriber, since the data, only this child have such data. No any other child have such data. So it's the unique child that can perform broadcasting between itself and the subscriber. So it's not necessary to check its local K and to make a comparison between the select K and its local K. So that is not necessary. Okay. So let us take a look at this dispatcher. Open this one. Okay. You can see here, that's the same. Okay, doesn't matter. This one, subscribe notification. This is forwarded from the root through unicasting. The root gets such information from the pub sub server, and then this notification is forwarded to its child through unicasting, right? Okay, so after this one notification is received, it must keep it locally. That means there is a local registry. This is one portion of the entire registry information in compared with this is not global, not just one portion of registry information based on the stream K. All the registry information related to this stream K are distributed to this child. That is why this child is not required to contact with the pub sub server and the registry server anymore, because it's already keep such information related to the stream K. All the registry information, the IP address, the subscriber information is already distributed to such child. So this child is responsible to broadcast the stream. This is the only choice, and it's not necessary for it to access the registry's mechanism to get those information, because those information already kept locally. Okay, this is a simple implementation. You can see this registry information is located at the child. But how for this solution, for the broadcast polling solution, there's no such implementation, right? No any registry information is here. However, for this case, this registry information is more complicated for such solution in terms of the child implementation. Okay, so it's necessary to perform unsubscription, right? If one subscriber leaves such a system, leave the stream framework. Okay, next, the stream. That is the same. That is the same. Okay, let us, when the stream is received, by a child in the polling multicasting solution, it needs to check whether it is selected or not. If so, the stream is need to perform polling, to access the register server to get a relevant IP address, and then perform broadcasting between itself and all the subscribers. However, let us take a look at this one. Okay, for this case, when the stream data is received, it's not necessary to perform this checking. Okay, it's not necessary to check whether it is selected or not. If this data, if one particular data is received, then it has to perform broadcasting. So it need to reset the children. Reset children because maybe new subscriber is available, right? So it need to get the IP address. This IP address already exists in its local registry, so no remote access the registry information is required. So this case, no polling is necessary. After that, this IP address, after that address is reset, then we can perform broadcast between the local child and all the subscribers. So okay, I think you must have already understood this solution. Okay, let us maybe okay, let us take a look at the pub server. It must get some, change something here. Okay, close all the windows. Okay, close it. Start this one. Okay, open this code. Code structure. Sometimes I do not need to. I think I do not need to repeat the statement that repeat the features of grid free. You can see all the structure, all the code, all the design patterns we have seen until now. At least they're same, right? They're same. No, although we reinvented some new APIs, we also implemented a couple of distributed frameworks. However, the code structure are same. Okay. Okay. For this case, for the new pub subserver, we need to keep the IP address of the root. However, for this case, it's not necessary. It's not necessary because the children in the multicasting work will access the server, the pub subserver. However, for this case, because it's forwarding, the pub subserver need to perform forwarding necessary information to the multicasting framework. So it's not necessary for such as it's necessary for the pub subserver to get IP address of the root of the multicasting framework. It can get such information from the according to remote this method. This method, you can see this method we just access the registry server. Okay, registry server get such IP address. Okay, next open this dispatcher. Okay, let us open another dispatcher. Open this another dispatcher. You can see here one one stream is this notification is sent from the publisher, right? So the publisher must want to post some new stream into the system, and then need to perform relevant registry. That's the same thing. You can see here the code is same. I do not re-implement anything. I just reuse this code. This code is the same thing. I just reuse. You can see the package, right? That's the same thing. For subscriber, no anything is updated. So I do not need to re-implement anything for the publisher. Okay, for this one, no anything is I just reuse this one. Okay, this one just reuse. Okay, for this case, this one is sent from subscriber, right? This one is different. You can see here the message is same. That message should be same. But let us take a look at this. After the registry information from subscribers are received, what the difference? For this case, for the polling broadcasting solution, it just is easy. The information is just keep local, keep the registry information on the local stream registry. However, for this case, first I need to I just mentioned this code, right? Just talk about that. First, need to perform subscribe, and then need to distribute it. This information need to forward. This registry information need to forward it. The public server need to forward this subscriber information, the IP address, and the interest to the root. So that's a different, right? Okay, that's unsubscribe. Okay, because for this solution, this is based on polling, so it's not necessary to forward anything. However, for this case, if subscribe information is received from the subscribers, need to first forward. This is forward, and then perform local unsubscription. Okay, what else we need to say about this code? Okay, this is string. This requires that should be same. This one is sent from the client. Let me think. This one is sent. I do not remember. This one should be sent from the subscriber, right? Subscriber need to know. What streams are available on within the streaming framework. So this one sent from subscriber. It should not be changed. That's the same. I do not change anything here. You can see, right? I just reuse this one. Reuse the public solution, the broadcast solution. Subscribers request. Let me check this one. Subscriber request. This one. Okay, let me see. This one is sent from the clan. You can see here. That's a little bit different, because for this case, it's necessary to process this request. This is subscriber's request. This one is subscriber request. It's different. This is subscribers. This is subscribe. This is subscriber. That's different. The subscribers, this is subscriber. So this requires is sent from the child. Sent from the child. Okay. This one is sent from the client. From the client. The client need to get IP address. Or you can see after this the information is received, because maybe there are a lot why this message need to be processed, why the client send such request to the pub sub server. Think there are usually multiple subscribers are interested in one particular stream. So which one, when the user enters such a system, which subscriber, you can see there are multiple subscribers here. So which subscriber will provide service for the new coming user. So the client or the user need to interact with the pub server to get one of them. So that means the pub sub server need to assign one subscriber to the user for streaming service. So you can see here random selection. So there is maybe multiple subscriber existing in the stream, right? In the stream registry, and then we need to perform random selection, and the one subscriber is selected, and after that the IP address is returned. The IP address is returned to the user. Okay, to the user. And then the client can access for perform search. Okay, that is why we need to the client need to interact with the pub sub server. Okay, I think we already almost finish all the code. Okay, the publisher, you can see publisher subscriber, we do not change anything. On the pub sub server. The client is different. The client is a little bit different. You can see here, this is the I re-implement the client. The client is here, right? There is another client in the broadcast solution. So let us take a look. But this change is not so important because the client is easy. So I do not. This change does not so important in terms of the grid free programming methodology. So not so important. Okay, let us take a look at difference. This client is very easy, so even though we change something, it's not necessary for us to spend much time. Okay, let us take a look. I implement that system maybe 2 or 3 days ago. I finished this implementation, so sometime maybe I do not remember that exactly. Okay, let us take a look. This is the set topic. That's the same, right? That's the same here. This one is different. This one. Okay. Okay, subscribers. Okay, subscribe. Oh, I see. That's a difference. You can see here, your user need to access the This one is sent to the pub sub server, but here it's different. If this request is sent from the user or the client, this is all value is false. If the message is sent from the child, then this is all field is true. So the server will check, the pub sub server will check whether this field is true, all field is true or false. If it's true, that means all the subscriber information will be sent to the children. However, if this message is sent is all field is false, that means only one subscriber is need to be returned to the client, to the user. So that's a not so so important difference, right? So for this case, that is not easy, not difficult to understand. So we do not need to expend much time on the client. It's just a little bit different, very simple difference. It's not necessary for us to implement a new message. This one, for this case, I implement a new message, subscriber request. For this case, the subscriber, we use subscribers request. That's almost the same, so it's not so difficult. Okay. I think I already finished all the code. I explain all the code. Explain all the code. So just make a simple brief conclusion. You can see the code structure. The code structure is the same. The design pattern is the same. Although we programming with another solution. Although we provide a more complete distributed system for this time. Okay, so we finish this class. I think I will show this demo, run such a system in the next lecture. Okay, if you have any questions, just let me know. Okay. Okay, that's all for this lecture. See you. Thank you for your watching. See you next time.